Okay, so this research paper you sent in, it's diving headfirst into AGI. And I gotta say, it's got me feeling a kind of mix of excitement, and like a little bit of, whoa, are we sure about this? You know, we're talking about artificial general intelligence here, right? The kind of AI that's not just good at one thing, but could think like we do, potentially. So in this deep dive, we're going to try to unpack the paper's main points. So don't worry, we'll keep it in plain English. Like, imagine us as your translators for all the dense, complex stuff, because it gets pretty deep. Because the big question is, how close are we to actually making a machine that can really think for itself? And then what does that even mean for us? What does that
Yeah.
world look like?
Yeah, and what's so fascinating here is that it's not just about making AI like smarter in the way we usually think about it with more data or whatever. It's about really replicating the core of what makes us human, you know? And this paper, it lays out a framework for what true AGI would need to be able to do. It's like almost like a blueprint for building a mind from scratch. It's kind of wild.
Oh, yeah, when I first read this thing, my mind was blown. Like, they're arguing that to get to AGI, we don't just need machines that process information. We need them to perceive the world, like through senses, sight, sound,
Right.
but also reason through problems, hold on to knowledge like we have memories, even develop some kind of self-awareness. It's like, are we trying to bottle consciousness here? It's a lot.
It is. It really is. And the thing is, some of this stuff isn't even that far off, which is kind of mind-blowing to think about.
Yeah, that's what really caught my eye too. Like, the paper's saying some of this is already happening. That's wild.
It is wild. We're seeing huge progress in what's called multimodal AI now. So instead of AI just being stuck in its own lane, like text over here, images over there, it's starting to understand the world more like how we experience it. Everything's kind of jumbled together, messy, different senses at once.
Okay, so it's breaking out of those silos,
Yeah.
getting a bigger picture.
Exactly. Like take GPT-4V, for example. You know how it can generate images from what you describe?
Yeah, that's already pretty amazing, the detail it can get.
Right, but it's not just copying. It's like it's actually conceptualizing.
Wait, seriously, so it's not just like matching keywords to a database of pictures?
Nope, you could tell it to paint, like a cat wearing a monocle riding a unicycle on the moon, and it could probably do it.
Hold on, for real. That's kind of blowing my mind a little. So, are we saying that we're on the verge of AI that can, like, watch a movie and actually understand what's going on? Like, the plot, the characters, all of it?
Well, let's not get ahead of ourselves. Multimodal AI is a huge step, but true AGI, that needs something more than just processing different types of data. It needs to be able to reason across those different things, like you said with the movie example.
Right, it's not enough to just see the pictures and hear the words. You got to connect all that to get the meaning, the story underneath.
Exactly. It's not enough for an AI to just see an image or hear a sound. To get to AGI, it needs to connect those senses, analyze them, think about the context, then use that information to make decisions, just like we do when we're watching a movie and understanding what's going on beyond just the surface level.
Right? Like, oh, that character did that because of what happened earlier, that kind of deeper understanding. Okay, that makes sense, but how do you even start teaching a machine to think like that?
Million dollar question, right? Researchers are coming at it from all angles. One really interesting area is building AI systems that can solve problems across totally different areas without having to be retrained for every single task.
So instead of being like a one-trick pony, this AI could what apply what it learns in one area to something totally different.
Exactly. Like think about how we learn. We can use, say, our understanding of physics to learn a new sport.
Yeah, like you kind of get how gravity and momentum work, so you can apply that to a tennis ball or whatever.
Right. We intuitively grasp these concepts and then we apply them to new stuff. That kind of flexible intelligence, that's what researchers are trying to build in AI.
Wow, AI that can connect the dots like that? That's incredible. But
Hmm.
I gotta say, it's also kind of like we're sailing into some uncharted territory here. And it's a little unnerving, honestly, to think about where this could all lead.
It is a brave new world, no doubt. And that leads to another big question this paper dives into, right? Like, how is this super smart AI actually going to interact with the world around it? Because it's one thing to be, solving equations in some digital void, but how do we get from there to AI that's actually out in the world?
That's where my brain goes straight to sci-fi mode,
Yeah.
Like we've been talking about AI mostly in this digital sense, but what about the real world? Are we talking like robots and stuff?
Sure. You're right on the money. The paper talks about how AGI will interface with both the digital world and the physical world. And in the digital, it's pretty wild. We're already seeing something called digitally embodied AI.
Digitally embodied. Okay, so that's like what AI having a virtual presence but not an actual body. like existing inside the computer.
You got it. Imagine like AI agents that are living and operating within digital spaces. They can use things like search engines, APIs, databases, all that to learn and adapt, even interact with each other.
So instead of us feeding them info, they can go out and explore the digital world on their own, like little digital explorers.
Exactly. They can gather info, test strategies, learn from what happens. The paper even talks about this example, Voyager.
Voyager, like the space probe, is sending AI into space now.
Not quite, haha, but kind of fitting name. Voyager is this AI agent that lives and learns inside the game Minecraft.
Wait, hold up. AI playing Minecraft. So it's not just numbers and code. It's actually like chopping down trees and building stuff.
You got it. And that's what's so cool about it, right? Voyager can set goals, make plans, even build these complex structures in the game, all while learning from what happens, adapting. It shows that AI can learn complex tasks in really unpredictable environments, just like the real world, but safely, you know.
Okay, that makes sense in the digital realm, but I think a lot of folks are wondering, how do we jump from Minecraft to like the real deal? That's where robots come in, right?
100%. Robots are huge GE when we're talking about AGI in the physical world. And the paper gets into how researchers are tackling those challenges. Like, how do you get a robot to actually understand what a human wants, not just follow pre-programmed instructions?
Right, because we've all seen the movies. It's not just about robots doing repetitive tasks in a factory anymore. It's about robots that get what we mean, even in messy, unpredictable situations.
Exactly. That takes a whole other level of AI, right? Like the paper talks about using these large language models so robots can interpret what we say, natural language, not just code.
So instead of programming every little step, you could just be like, hey, grab me that thing, and it would actually understand.
That's the dream. Bridge that gap between how we talk to each other and how we interact with machines. There's a project mentioned, SayCan. They're already making some cool progress there, using Google's Palm language model with robotics.
Okay, that's impressive, but got to be real for a sec. Robots aren't exactly known for being graceful. You know? How are researchers tackling that whole thing of making robots move more human-like without, knocking over all our furniture?
Haha, yeah, that's a big one. The paper talks about motion GPT, which is pretty wild. It uses AI to analyze and then replicate how WE move with crazy precision.
Motion GPT. So it's like translating our movements into a language robots can get.
Exactly. Understanding the little things or balance, coordination, stuff we don't even think about, could lead to some seriously agile robots.
Okay, my brain is like officially at capacity here. We're talking about AI that learns, adapts, maybe even moves like us someday. It's amazing, but also, like, where do we even go from here? What's next on this whole AGI roadmap?
Well, that's where things get really interesting. The paper, it actually lays out this framework for understanding how AGI development could go, kind of like levels in a video game almost.
Levels, huh? So AI is leveling up its intelligence. I got to hear more about this.
Right. So right now we're at what they call level 1. Basically, AI can do specific things really well, often better than us even, but it's still kind of limited in what it can do, like a really powerful calculator that hasn't quite grasped algebra yet.
Okay, yeah, level 1 is impressive and all, but
Yeah.
it sounds like it's just scratching the surface of what AGI could really be. What happens at these higher levels?
Level 2, that's where things get really wild. This is like superhuman AGI territory. AI systems that could actually be better than humans at a whole bunch of things, not just one specific task. Like, imagine an AI that could not only solve those complex equations, but also compose music, design new medicines, even read a novel that'd blow your mind.
Okay, now that is both incredibly cool and also a little bit, gulp, makes it swallow hard, right? It's like we're unlocking this crazy potential, but also there's a lot of unknowns. How do we make sure that whatever we build, we can still control it, especially if it's potentially smarter than us?
Yeah, you're hitting on the big question there. The paper stresses that as we're figuring out level 2 AGI, we got to be really conscious of 3 things: alignment, fairness, and safety.
So it's not just about making it smarter, but making sure it's got, like, good intentions.
Yeah.
That it's not going to go all sci-fi villain on us.
Exactly. It can't just be, oh, it's powerful, that's all that matters. We need to make sure it understands our values, that it's not going to make things more biased, and yeah, that it's ultimately not a threat. That's the ideal, at least.
Which, I'm not going to lie, sounds kind of tricky.
Hmm.
Especially when we're talking about something that could outthink us.
It is a huge challenge, for sure. And it's not just on the tech people to figure this out, We need everyone, ethicists, philosophers, policymakers, everyone to be thinking about this stuff. It's bigger than just code.
Yeah, like we're building this incredibly powerful tool. We got to make sure it comes with a really good instruction manual and some safety features too while we're at it.
100%. And even then, there are no guarantees, right? That's the thing about the unknown. We gotta acknowledge the risks, even while we're excited about what AGI could do. Imagine, like, AI helping us solve climate change, cure diseases, stuff we can barely dream of right now. It's a lot to take in.
It really is. This whole deep dive, it's been eye-opening, but honestly, I have even more questions now. But hey, isn't that kind of the point, right? To push those boundaries and get us all thinking.
I think so. And the biggest thing to remember is we get to shape what this future looks like. It's not some predetermined thing.
Well said. All right, folks, that was a lot to unpack. Big thanks to our listener for sending in this mind-bending research paper. Hopefully this got you thinking even more about the age of AI because it's coming, whether we're ready or not.